So it's 10 o'clock here in the Netherlands, 9 o'clock in the UK. Hello, welcome to today's Energy Tech Talks. My name is Eric Nijveld, CEO and co-founder of technologycatalog.com. I'm your host for the webinar today. And today's webinar is organized together with TAQA Well Completions, a company that provides industry-leading completion solutions and well services. So James Boyle will deliver the presentation. James is the Eastern Hemisphere champion for the system presented in this webinar. If you have any questions, please type them in the Q&A box on the left-hand side of the screen, and we will go through the Q&A following the presentation. And with that, I would like to hand over to James.
That's great. Thank you very much for the introduction, Eric. And thank you as well for the opportunity to host and to present our technology. So I'll dive straight in. What we're going to talk about today is the current challenges that the industry faces with downhole shut-in valves. I'm going to talk about existing solutions to these challenges, and I'm going to talk about TAQA's Pulsate Secure, which is an intelligent safety valve and offers a novel take on the solution to existing global issues with downhole safety valves. So the current challenges that the industry faces with downhole safety valves in particular ultimately leads to lost production, which of course is a big issue. There's currently hundreds, probably thousands of wells globally which suffer from this issue. It's an increasing problem with aging systems and a limited life cycle on downhole safety valves. So it's a global issue which we're all facing. Currently in the UK North Sea, 31% of well integrity issues are due to downhole safety valves. So that is obviously having a big impact on production, not just here, but around the world. The other issue, of course, is the infrequent testing regime that we currently conduct on our existing safety valves, which means there's potentially a high period between testing for us to recognize if one of these valves is not functioning correctly, or indeed if it has failed. So traditional solutions, obviously we can perform a workover to replace the existing failed valve. That has a very high cost associated with it, obviously. So a insert valve or a retrofit valve is always going to be a preferable option to that. Traditional insert valves or traditional retrofit valves come in the form of storm chokes or velocity valves. Often one of the issues with these is that they have a very limited window in which they can operate. And for that reason, when we produce the well, we have to restrict production to maintain the pressure window or the pressure or the flow rate within that operating window. It becomes technically difficult to actually test these valves because we have to drop the pressure out with that window in order to trigger the valve and test it. So that means we're restricting production, which of course has a cost associated with it as well. It takes frequent intervention often to recalibrate these valves and to perform maintenance on them. Once the well later in life will drift outside of its operating window, due to depletion or slugging events, then the valve becomes inoperable. And just to put a number on that, the average cost of an intervention in the UK North Sea currently is about $450,000. So it's not a cheap solution to be constantly calibrating and resetting these valves. So the pulsate secure. I'll start with an outline of the valve, the physical setup of the valve. It consists of a battery module. The batteries power the electronics, which is essentially the brain. There's a PCB, printed circuit board inside there, which is connected to the various sensors of the valve. And the brain, the PCB, makes decisions based on inputs from those sensors. So that's 2 pressure sensors and a position sensor. The outcome of those decisions from the brain will drive the actuator, so that's internal motors, which in turn move the choke to various positions. In the case of the secure, that's an open-closed position, primarily, in order to secure the well. Above that, of course, we have the hanging device, or some kind of suspension device. Typically a lock mandrel or a retrievable packer. The tool's deployed using just standard intervention techniques, so that's typically slick line. You can also deploy on coiled tubing, or in horizontal sections we can use tractors to deploy. So yeah, standard intervention methods to deploy the tool. Nothing exotic there. So the secure is an autonomous intelligent safety valve. It's programmable. What that means is that we will program the tool to each individual well in order to respond to the pressure events of that particular well. So we'll work with our customers to determine where the triggers, what pressure responses the tool should recognize as a safety event, and it will respond and close to those particular events. Self-powered, as I said, it uses batteries which can last up to 5 years. The tool is intelligent, so it's programmed and configured to make decisions on what is a normal, healthy flowing well, normal production, and what is out with normal production. The tool also can communicate from its setting position downhole up to surface. I'll talk more about that later, but what it essentially tells us on a daily basis is an analysis of its own health. It communicates that to surface, and that gives us reassurance on a daily basis that we have a functioning safety valve downhole. Cost effective and reliable. So as I said, well, as a retrofit solution, it will eliminate the need for a workover to replace a failed tubing retrievable safety valve. And it's fully tested to API standards for production and for injection purposes. So a bit of detail on the functionality of the tool. It is a novel technology. As I mentioned, it is programmable. So the tool responds to various triggers, which is unique to the secure. So traditional safety valve will be a traditional insert valve will respond to a single trigger. So that's one absolute pressure, which is programmed, which is configured onto the tool. What the secure does is it monitors the normal production trend, and it makes decisions based on pressures out with that normal production trend. So you can see the plots on the right there, that the normal production trend over time, the well will deplete, that production trend will drop. There will also be potentially slugging events during a normal flow period, during a normal life cycle of a well. What the secure does is it bases its trigger pressures on the rate of change out with that normal production trend. So if there's a high rate of change of pressure, the secure will have been configured to recognize that as an emergency shutdown condition. And within 8 seconds of having recognized that trigger has been passed, it will shut in the well. Equally, for a loss of surface containment event, during that kind of event, there will be a rapid drop in pressure. What the secure will do is recognize that as a loss of surface containment for that particular well, and it will make the decision to shut in and secure the well. So those are what we call the dynamic triggers. We also have the ability to set an absolute trigger. So that is a value at which we know the pressure in the well will never drop to. And it's an absolute backup trigger to the rate of change triggers. We can also set a higher absolute trigger, which we're currently using for high integrity pressure protection systems. So that's where we know that a well should never go above a certain value. Then the secure will trigger and it will protect our surface equipment from that well pressure. The secure has features for managing well startup. So if there's a particularly volatile startup where there's rapid pressure drops and starting up the well will trigger traditional valves with their single trigger point. What the secure can do is we can program it to anticipate this volatile pressure during startup and not trigger during that period of time. Once that period of time has passed, the tool will wake up, it will become alive, and it will start monitoring the activation pressures. The way we open the tool is also wirelessly. It's a very easy process, designed again to suit well conditions. So by using a staged pressure application, the tool recognizes this open command that we generate from surface, and it will open.
Hey James, there's a little screen, a little black screen. I think you can click that away actually.
This one?
Yeah.
The one I keep moving around, okay.
That's right, yeah.
There we go.
Perfect, yeah, thanks.
Okay. Yeah, thanks, Eric. So those are the basic features of the tool. I'll talk about some of them in a little more detail. So the vitality pulse, which I touched on a minute ago, this is unique to the secure, and really what we do here is we leverage the tool's downhole intelligence and also the fact that it has a variable choke position. What the vitality pulse is the tool moves its choke to a partially choked position on a daily basis. So for example, at midnight every day, the tool will partially choke the well. What that does is it generates a pressure pulse in the flow of the well. And that pressure pulse can be detected on surface just by monitoring the tubing head pressure, just using typically just existing sensors, as you can see on the plot here. So daily basis, midnight, the tool briefly, typically for 5, maybe 10 minutes, will partially choke the well. We see that on surface. Now, what does that tell us? It tells us that the secure is alive and well downhole. So that's a daily test of the power source. It's a daily test of the actuator section, which is the drive mechanism of the tool. It's a daily test of both annulus, well, what we call annulus and tubing sensors. So that's both pressure sensors on the tool are fully functional. And it also communicates to us what its actual battery voltage is. So what this essentially means is that we never go more than 24 hours without confirmation that all of these crucial parts of our downhole safety device are fully functioning. So we're essentially never more than 24 hours between a pretty thorough health check of our safety valve. which is unique not just in retrofit or insert safety valves, but is also unique in traditional tubing retrievable safety valves. It also communicates its actual battery voltage to us. The way it does that is by the spacing of those vitality pulses. So the sharp-eyed amongst you will notice that those vitality pulses are not all equally spaced, and that's deliberate. So by offsetting alternative vitality pulses, the tool is actually communicating its measured battery voltage. And what that does is gives us plenty of time to recognize when the voltage starts dropping, and we communicate that to the customer, or the customer will recognize that themselves typically, and we can arrange an intervention to replace the batteries. So that's the vitality pulse, which is a key differentiator in this technology. So the tool is API 14A qualified, as I mentioned before. This video, which is, there we go, it's playing now. This is in real time. So that's the actual choke closing. This is on what we call the 3.5-inch tool, which is designed for 3.5-inch tubing and above. It closes within 8 seconds. Here it is opening again. So about 8 seconds for it to close the ports, which seals off 95% of the production. And then within 22 seconds, the choke is fully engaged in the seals, creates that V2 seal, and that's within the API standards. Of course, what we also have to do is open the Pulsate Secure. Again, what we will do is we will configure the opening method to suit individual wells. So we have two methods of opening the tool, and these are done by step changes in pressure. So typically when the secure is closed, there will be some trap pressure above there, and so what most of our clients will do is simply bleed off that trapped pressure at stepped intervals. So we'll configure the tool to recognize when it sees a drop in pressure of a pre-configured value, maybe 50 psi, for example, within a certain period of time. It will recognize that as a step change in pressure, and it will log that. Then within a gap time or a hold period, after that hold period, if it recognizes a second step change in pressure, it will log that. Sometimes we'll configure it to have 2 steps as a valid open command, so it will recognize the second step, and it will understand that we've just sent a command to reopen. Equally, what we can do is pressure up from surface, so we can use a gas jumper line or nitrogen to create 2 steps, or up to 4 steps is available. Typically 2 is sufficient in order to send an open command by pressuring up above the tool. What we're aiming to do here is to generate a command that is deliberate and distinct, so that it is a recognizable instruction from surface. At the same time, we don't want to make these open commands too simple, in which might be generated by mistake. So that's again, that's configurable to individual wells and to individual customers' needs. So just a comparison on the secure valve versus traditional solutions. Hopefully this will highlight that this is a step change in the offering of downhole safety valves. So I'll just work through this table to start with the production rate, and this really is key when it comes to return on investment. So that is in a traditional valve, the production rate does have to be restricted. Now that is to ensure that the valve will operate within a certain window, and that window has to be out with the maximum flow rate of the well. The reason for that is that in order to test the valve, the pressure has to be reduced or dropped to a level where the valve will trigger. And yeah, so that restricts the production rate of a storm choke or of a velocity type valve. The difference with the pulsate secure is that we can flow the well at its maximum rate, and that's down to the fact that the pulsate secure has the dynamic triggers. So if we want to test the pulsate secure, we can flow the well at its maximum rate. If we want to close the valve, we simply shut in the well on surface. The pressure will spike and rise. The valve will recognize that as an emergency shutdown situation. It'll recognize that spike as a closure trigger. And it will, of course, close within and seal within the 22 seconds. We can then bleed off the pressure above, conduct an inflow test, and that's additional assurance that the valve is fully functional. I say additional because it's on top of the daily vitality pulses that the secure is already sending to us. The testing, as I've already covered, in traditional tools is often infrequent. It's done depending on the customer and the regulators. It's done on a regular basis, but there is inevitably a big time between testing where there's no guarantee that there's a functioning safety valve downhole. So, the only time a problem with a safety valve is recognized is when it's tested. So there's a period of often months where there may be the belief that there's a functioning safety valve downhole, and in actual fact, that's not the case. So hopefully that is caught during a test and not when we actually need to rely on the safety valve to keep us safe. Pulsate secure, like I said, it's very easy to trigger the tool closed. Multiple options in which to do that, and to do an inflow test on the tool and on the suspension device. And like I said, we have the daily vitality pulse. Activation, again, touched on. Traditional single trigger, pulsate secure, 4 active triggers, intelligently always monitoring pressure and autonomously making decisions instantly on when it sees a pressure situation or a pressure signature which is outside normal flowing conditions, and it will close. The other big difference here is the opening scenario. So traditionally, when I'm making comparisons with storm chokes, we need to equalize from surface in order to open the traditional retrofit safety valves. With a pulsate secure, we can open the tool by sending the previously mentioned open command, again configurable to the well and to whichever surface equipment we have in order to best meet our opening commands. One key factor is that we do not need to equalize across the secure in order to open it. It can open with the differential pressure across the tool. So if we have as much as 1500 psi pressure across the tool, we can still send an open command to the tool and it will open with that differential. So that's another key differentiator of the secure versus a traditional valve, is the opening differential. So there we have it. That's a quick touch on the comparison between the two tools. And that's all I have for you today. It's been a very brief overview of the Pulse 8 Secure, which is, like I said at the start, it's one of our suite of downhole intelligent safety valves, downhole intelligent valves, I should say. In addition to that, we have the ICV and we have the wireless gauge. So that's the Secure covered for today. Any questions, I'll be happy to answer.
Hey, thanks, James, for this overview. So I can clearly see that this is a tool with, that has a lot of impact. And given the number of wells around the globe with issues, the applicable base is significant. Good. So I see a couple of questions coming in already. And one question, great overview, James. What is your track record of deployment and success?
Track record is good. It's a new technology. So since the tool was made fully commercial, which we deemed that to be at the point where we got the API qualification on the tool, we have, I don't have the numbers in front of me, I should have, but we have made multiple deployments, predominantly in the North Sea, because that's on our doorstep. So when it comes to success, we currently have 2 tools in the ground which have been fully functioning for over 2 years now. So one of those we are hoping to go and replace the batteries on in the near future. We have multiple tools in the North Sea which have been functioning and confirming their function for over a year. I say confirming their function because we received the daily vitality pulse from those tools.
Hey, the battery lifespan is up to 5 years, and are TAQA looking at technology to extend this?
Yes, we are. So we have a team of people who are constantly looking at battery technology, and I'm sure we're no different to multiple, not just companies, but multiple industries around the world who are looking to improve battery technology. So we have different chemistries available to us, which work better in different scenarios. So that's typically temperature is the biggest factor when it comes to battery life. Other solutions, of course, are downhole power generation, which is something else that is being considered. And yeah, so we're constantly improving not just battery technology, but the way in which the tool uses power is key. So, making incremental improvements on that will, of course, extend the life of the tool downhole.
Excellent. Hey, and James, you made a comparison between Pulse 8 and traditional systems. Can you say something about the return on investment of your system compared to the traditional way of doing things?
Yeah, so return on investment, well, the key return on investment is going to be by achieving, the increased production. So that's the difference between the Secure, which allows an operator to flow their well at their preferred rate, versus traditional systems which do require the well to be choked in order to maintain the operating window of that traditional system. So I suppose the easy answer to that would be to look at the increment, or look at the difference in production rates between the traditional system, which has a reduced rate, and between the Secure, which offers the well to be produced at its maximum rate. So, we've had some customers which have, covered the cost of the tool, within a matter of days or weeks of the tool being deployed because of that improvement in rate of production.
Excellent. There are a couple of other questions. So thanks for the great presentation. What happens if there's a rapid change in pressure at surface that triggered an ESD of the pulsate, but the pressure change is not actually well integrity related?
Yeah, and that's another key differentiator between the secure and a traditional insert valve, is that the secure will recognize an ESD as a safety event in the same way that a tubing retrievable safety valve would. It'll recognize that pressure spike, and it will shut in downhole, within the API standard of 22 seconds. So it provides that second barrier downhole when it recognizes an ESD. Traditional tools will not do that. So that's a key differentiator.
Yeah, excellent. Hey, and going back to the battery topic, what actually happens if power is depleted while the device is downhole?
Sorry, say that again.
What happens if the power is depleted while the device is downhole? Yeah,
so that's another feature of the tool, is that because it's essentially intelligent, it's got its onboard computer which is constantly monitoring its health and its condition. There's a few things the tool will do when it recognizes its battery is depleting. One is that it will, by using that shift in its vitality pulse position on a daily basis, it's constantly communicating to us what its battery voltage is. So we'll have on a daily basis confirmation of the power available to the tool. The second thing it will do is, when it recognizes that its battery voltage has dropped to a certain level, it will make the decision that in the near future, it will no longer have its optimum power in order to shut in the well. So it will make that decision there that it will shut in. So it's going to decide, my battery is now depleted to a level where I need to shut in and lock and close the well. So that's a secondary option. When the battery does become depleted, it will fail closed essentially.
Yeah, excellent. So it's a clever system which sends notifications effectively.
Exactly. Yeah.
So how does it deal with high temperature?
It deals with high temperature. So the real limitation on temperature is the batteries. So typically, as with any battery, the higher the temperature, the bigger an effect it has on the life of the tool. So we typically, are happy to run the secure in wells up to 110 degrees. We have run it in wells higher than that, up to 125 degrees. But what the key factor once you get above 110 is the life of the battery. So it copes, but the more frequent battery changeouts are required once you start looking at higher temperatures.
And yeah, excellent. And linked to this, can you give an overview of the key product specifications? So besides temperature.
Yes, I actually printed these out so that I would get them right. So, well, one thing that I didn't mention, which I should have, is that we currently have two versions of the secure, one of which is what we call the 3.5-inch tool. It's designed for 3.5-inch tubing and above. We also have what we call the 7-inch tool, and that's designed to be deployed in 7-inch casing. So that's for higher flow rate wells. So the maximum rate through the smaller tool, we say 10,000 barrels of oil per day. Obviously, if there's a mixture of fluids, then we need to look at that on an individual basis. Sealing mechanism, 9,000 psi. It can open, crucially, with a 1,500 psi differential across it. Yeah, and those values are similar for the bigger tool. The maximum rate of the 7-inch tool we quote as being 30,000 barrels per day. Again, if it's mixed fluids, then what we'll have to do is an analysis on the rate for that specific well and those specific conditions.
Okay, excellent. So it has a fairly broad application range, we can say.
Yeah, so I mean, key is that we have different size tools for different completion sizes.
And linked to this question, so what applications have you run the tool on in the North Sea?
So in the North Sea, the primary application in the North Sea is the secure. So that's the intelligent valve functioning and configured and programmed as a safety valve, like I've touched on. We've multiple configurations of it. So we have some installations where we have all triggers activated. So that's the tool fully functioning on dynamic triggers and on the absolute trigger. We also have, I think, maybe 1 or 2 installations where the client has chosen to install the tool with only the absolute trigger activated, which is an option. All 4 of the triggers can be activated or not. We also have multiple tools installed in the North Sea, which are inflow control valves. So I've not talked about that at all today. It's really another presentation, but it's another variety of the intelligent valve from TAQA, where we install the valve down at reservoir depth. And what it does there is it controls production from the reservoir directly. So if there's water breakthrough, what we can do is send a command from surface to the ICV, and we can tell it to choke back the zone which is producing water in order to reduce water rates to surface. The ICV and the wireless gauge can also, by manipulating the flow of the well, by choking the well, similar to a vitality pulse, but it's like multiple vitality pulses. They can communicate to surface, so they can transmit pressure, temperature, and also various parameters on its status to surface. So that's, yeah, it's really it's another presentation, which perhaps I'll do another time, which is on the other intelligent valves that we offer.
Yeah, excellent. There are a couple of more very specific questions. So it looks like people are very keen to understand whether the tool applies for their wells. So one of them is the tool compatible with high H2S wells, and has it been deployed in such wells before?
So the answer to that is yes to both. So we do have Inconel sour service version of the tool. So that, yeah, and we can absolutely deploy that in a high H2S environment. We have deployed in high H2S environments already.
Yeah, excellent. So another question, I'm not sure whether I don't think you covered that in your presentation. Do you have experience on velocity string application, e.g. 2-inch or 2 or 3/8-inch coiled tubing outer diameter?
Okay. We do have experience. So we have installed a secure in a velocity string situation. So that was quite a particular installation that we did. So what the velocity string did for this customer was obviously help offload water from the well by increasing the velocity and the lift. A result of that was that the velocity string itself held open the existing tubing retrievable safety valve. So that put them in the situation where they had no functioning safety valve. And that's where, the secure really was an ideal solution for them. Insert safety valve set above the velocity string. So that was in the 7-inch section of the well, which introduced and provided for them an additional barrier.
Excellent. A question from the same person. Are there any papers on Pulse 8, for example, SPE papers?
Yes, there are SPE papers. I could probably get a link to them, or I have Maribel in the room with me here who can probably help with that. So yeah, I don't know if Eric, there's a way of putting links to the to this once we're finished. People can...
We'll share the recording, and also in this specific case, question asked by Mauricio. Mauricio will then get the link to you, but also the link to the recording will be shared, and all the people that registered for the webinar will receive a automated note. But we can also make sure, and also looking here in the room to Martina, we can make sure that we add a link to the SPE papers there.
Perfect. And my email address is on the screen, so people should feel free to contact me directly for any questions that may come up later.
Yeah, absolutely. And there are, I think, a few more questions. A question here. We are familiar with the hydraulic actuation of safety valves. Can you just expand on how the pulse actuation and signals work, and any possible interference risk to consider? Any possible interference risk?
Interference risk. So I'm guessing that question is about interference from an existing safety valve. So typically, if there is an existing tubing retrievable safety valve that has failed, which is what I touched on at the start, currently 31% of well integrity issues in the UK North Sea are due to failed existing valves. So typically that would be isolated. So if that, for example, was due to a blocked or a leaking control line, which seems to be the most common reason for these failures, then that control line would be isolated, and the existing tubing retrievable valve would be locked in an open position. So that can be done with a hold open sleeve, or it can be locked with pressure. So the well will be in that condition when we insert our secure. So that removes the risk of interference from the existing valve. I suppose the other interference could be from the pressure response from the well. The tool is designed to recognize a pressure signature, I suppose, which would represent a safety event. There are other pressure events in a well, particularly during startup, and if there's slugging flow in the well, which could potentially trigger the tool if it were to recognize, those events as an ESD or as a loss of containment. So what we do is we anticipate you anticipate those flow conditions, typically during startup, and we tell the tool, we'll work typically with production engineers, and we'll look at existing data, and we will instruct the tool that, yes, during these periods of time, so that's on startup and maybe shortly after a vitality pulse, there will be unstable flow. And so you should not recognize those instabilities as a safety event during those periods of time.
Excellent. It was great to see the many questions. And James, many thanks for the insightful presentation. There's a clear trend around the world to make the most of existing assets, and the tool that you presented and the TAQA Well Completions capability in general, yeah, there's a clear link with indeed making the most of the existing assets. So I can see that there's a clear need for what you do, a clear market pool. So many thanks for the presentation. Many thanks to those.
Thank you, Eric.
And many thanks to those that attended today. The recording will be made available. And wish you all a great rest of the day.
Yeah,
many
excellent.
thanks.
Yeah, no, thanks again, Eric. It's been a pleasure.
Thanks, James. All the best.
Yep, and you. Bye-bye.